See students, in stearic acid there is no double bond, there is no carbon-carbon double bond, and that is why the decolorization of iodine will not take place because iodine atoms will not be used up. Then in oleic acid there is one carbon-carbon double bond, and that is why the decolorization will take place of iodine. In palmitic acid again there are no carbon-carbon double bond, and that is why there will be no change into the iodine solution, to the color of the iodine solution. Then in linoleic acid, two carbon-carbon double bonds are present, and that is where the decolorization of iodine will take place over here. Now let's move towards the next segment. See, the unsaturated compound can also undergo addition reaction with hydrogen to form a saturated compound. However, it is necessary to use a catalyst like platinum or nickel for this. We have already seen that catalyst is such a substance due to presence of which rate of reaction changes without causing any disturbance to it. And then I have taught you in chapter 3rd that what is catalyst. Catalyst is that substance which do not takes actual part into the chemical reaction, but it changes the rate of reaction, or it accelerates the rate of reaction. It helps in easy reaction to go, and that is why we should use catalyst here into the hydrogenation of some alkenes. So here the example is given that when alkenes are subjected to reduction, that means addition of hydrogen, we should use catalyst like platinum, this is white gold, or nickel, or palladium also, whose symbol is Pt. So this nickel, platinum or palladium, this can act as a catalyst whenever the reduction will take place of any alkene or any unsaturated hydrocarbon. So whenever unsaturated hydrocarbons are subjected to hydrogenation, it results into formation of saturated hydrocarbon. That means alkenes can change to alkanes on reduction. So here this reaction is used for hydrogenation of vegetable oils in presence of nickel catalyst. You have seen in the above activity that iodine test indicates presence of multiple bonds, double bond in particular in the molecules of oils, while vanaspati ghee is found to be saturated. The molecules of vegetable oil contain long and unsaturated carbon chains. That means the molecules of any vegetable oil, if you are taking, that will contain unsaturated carbon atoms, double bonds will be there, one or more than one. Then we have to do hydrogenation, that means we have to do reduction of such kind of vegetable oils, and because of that hydrogenation, it will result into formation of saturated chain, and this is how vanaspati ghee will be formed. Then unsaturated fats contain double bonds, are healthy, while saturated fats are harmful to health. So unsaturated fats which contains double bonds, these are healthy for our body. That means vegetable oil are healthier than that of the ghee, while saturated fats are harmful to the health. That is why consumption of vanaspati ghee, I'm not talking about the desi ghee which is good for the health, vanaspati ghee, consumption of more vanaspati ghee can be harmful, and that can increase the level of cholesterol into our body, while unsaturated fats which contains double bonds are healthy for the body. Okay, so what I wanted to tell you is that whenever unsaturated hydrocarbons are subjected to reduction under the influence of any catalyst like nickel, platinum or palladium, it results into formation of saturated hydrocarbons. So in this way only hydrogenation of vegetable oil is brought about in the presence of nickel catalyst, and then it results into formation of vanaspati ghee. Now the next reaction is substitution reaction. Substitution means replacement will take place. That means you can see this is methane. If methane is coming in contact with chlorine molecule in presence of sunlight, then one hydrogen will be removed, and then that place of one hydrogen will be taken by chlorine atom, and then as a byproduct, that hydrogen, that one hydrogen which was replaced by chlorine atom, that hydrogen will combine with the leftover chlorine atom and results into formation of HCl. So then it will result into formation of methyl chloride and HCl, that means hydrogen chloride as a byproduct. Then the same product which has been formed when it is again subjected to chlorination into the presence of sunlight, it results into formation of CH2Cl2, that means methylene dichloride. That means two atoms of chlorine will be there, and then one more hydrogen atom will be removed. That one hydrogen atom will be replaced by one chlorine atom, and then again we will get the byproduct hydrogen chloride. Then when the same methylene dichloride is subjected to chlorination, it will result into formation of methylene trichloride, and again HCl will be formed as a byproduct. When the same methylene trichloride is subjected to chlorination into the presence of sunlight, it will result in the formation of carbon tetrachloride. That means all the four atoms of hydrogen will be replaced by chlorine, and HCl will be formed as a byproduct. And then still larger number of products are formed in chlorination reaction of higher homologues of alkanes. So if you'll move further, you can find that more atoms of hydrogen, because if you are moving towards a higher alkane will have more hydrogen atoms, because methane was having only 4 hydrogen atoms, and those all hydrogen atoms has been replaced by chlorine over here. So when you will move towards higher alkane, you will find more hydrogen atoms which will be replaced by more chlorine atoms, and this is how you can have uh, larger number of products after chlorination whenever you move towards higher alkane. So this is how the process can go on, and this chlorination will take place into the presence of diffused sunlight, and this sunlight will act as a catalyst over here.